Hello everyone, today I am going to calculate the area bounded by my curve using the change variables in double integrals. Here is my function. This x squared divided by a squared plus y squared divided by b squared again squared equals x squared divided by h squared plus y squared divided by k squared. Primarily, let's simplify our equation. For this reason, we take x and y as polar coordinates. So x equals AR cosine theta and y will be BR sine theta. Now let's find our Jacobian. For this reason, we will find four derivatives. First of all, let's find the derivative of x by r equals a cosine theta. Then the derivative of y by r equals b sine theta. And the derivative of x by theta equals minus a r sine theta. And the derivative of y by theta equals b r cosine theta. As we know, the formula of Jacobian is like that. The derivative of x divided by r multiply the derivative of y by theta minus the derivative of x divided by theta multiply the derivative of y by r, and if we put these derivatives which we found into this equation, we will get a b r. So then let's change our coordinates and find r to determine the boundaries of our integral. If we will put x and y into this equation, we will get this formula. And again, we will simplify, we will get this equation. Here, a and b cancel each other. Also, we will put r squared out of the brackets. And here, cosine theta squared plus sine theta squared, as we know, equals 1. And then we will get again like this formula, and here again r cancel each other, that's why we will get this formula. And at the end we can find our r, which is square root of a squared multiply cosine theta squared divided by h squared plus b squared multiply sine squared divided by k squared. Now we can graph our equation to determine the limits of integration. So if from our equation a, b, h and k is 1, our graph will be so. As you can see, we can take r from 0 to square root of again a squared multiply cosine theta squared divided by h squared plus b squared multiply sine squared divided by k squared. And we can take our theta from 0 to 2 pi, because our graph is circle and a loop is in whole graph. So we can only evaluate our area. As we know, the formula for a is so 1 multiply j or Jacobian dr d theta. So let's get started. If we put our formulas and equations into this formula, we will get the integral from 0 to 2 pi, and again integral from 0 to this equation, and it is our Jacobian ABR diğer d theta equals, first of all we will calculate first integral. That's why it will be the integral from 0 to 2 pi ab r squared divided by 2 from 0 to this equation d theta, and again equals, if you put this equation into this formula, we will get a the integral from 0 to 2 pi ab multiply a squared multiply cosine theta squared divided by h squared plus b squared multiply sine squared divided by k squared divided by again 2 d theta. And here we will find this equation, and if we let's put our constant out of the integral, that's why we will get like this formula. And to calculate this integral, we must evaluate them separately. That's why we have to write like that our integral. And again, if we evaluate this integral separately, we will get this answer. So ab divided by 2 multiply h squared multiply p divided by h squared plus b squared multiply p divided by k squared, and it will equal PAB divided by 2 multiply h squared plus divided by h squared plus b squared divided by k squared. And here is the formulas which I used during the calculation. That's all. I hope you enjoyed it. Thank you for your attention.